Hello everyone and welcome back to Configure This Now. My name is Tim Haney, and in this video we're going to be talking about master redundancy, centralized licensing, joining locals to masters, and control plane security. As a reminder, please go ahead and turn on your YouTube annotations in case there's any on-screen corrections that need to be made after the video gets uploaded to YouTube. Here's my standard disclaimer. You can pause and read that, but basically I'm just saying I'm not responsible for anything that you do with this information. Okay? Here's my network diagram. I broke this diagram down in the first video of this series, so I'm not going to do that again. However, since we are talking about master redundancy, I am going to make a quick note. So here are my two master controllers. Master redundancy relies on VRRP to determine who the active master should be. And this is going to create a few important caveats that we need to be aware of when we're configuring this. Okay, but it also implies that your master controllers do need to be on the same VLAN so that they can exchange the VRRP packets and figure out who should be the active master. Additionally, any of the local controllers are going to point to our VRRP address here, 10.0.10.4. They're not going to point to the .2 or the .3. They will only point to whoever the active master is. Okay. All that being said, let's go ahead and jump right in. Okay, so I'll go ahead and launch my Super Putty. And I'll open up both of my master controllers. And this weird skewing of the banner is really just a fault of Super Putty. It's not from the Aruba controller. Alright, so as we mentioned, master redundancy relies on VRRP, so let's configure that first. So, very simple commands, VRRP 10. Let's give it a description. Master redundancy VRRP instance. Okay, it's going to have the IP address of 10.0.10.4, and we have to assign it to its own VLAN, VLAN 10. And I'm not going to unshut it right now. I'm going to go over to here and VRRP 10, same thing. Description, master redundancy VRRP instance, IP address 10.0.10.4, VLAN 10. Remember, these master controllers are in their own VLAN, VLAN 10, and their IP addresses are .2 and .3, as you can see. Okay? Now, first big warning here. Alright, so as I mentioned, it's very important that we always know who the correct master should be. Okay? Even when we're getting this set up for the first time. Because if a controller that does not have the same licensing level or does not have the same configuration as another controller becomes active, a lot of things are going to be lost. So I make the specific example here. Let's say one controller has the PFNG license and the other does not. Okay, certain default user roles get configured a certain way by default after adding the PFNG license. However, if you set up master redundancy and the wrong controller becomes active, those default configurations get wiped out. And the same thing happens for any other configuration that may exist on that controller. It's going to get wiped out. Okay, not your basic route switch settings, but just like the relevant Wi-Fi configurations. Okay, so I'm going to demonstrate that for you so you can be aware of how this is going to happen. Alright, so on this controller, this is master 1. First of all, I'll say show license. So you can see I have all three types of licenses installed here, and on this one, show license. Okay, no licenses. So what does that really mean here? What kind of impact does that have? Well, let's do a show run pipe begin user role. This is exactly what I was talking about. Okay. As far as user roles go here, this is all we have. Very little. And if we come over to here, show run begin user role, we have way more roles and way more access lists in those roles already set up for us, okay? And that's because we added the PEFNG license. When we added that license, all of this extra configuration unlocked, okay? And to further demonstrate the point I'm trying to make here, let's go ahead and go to Master Controller 1, which is where all these licenses are. Let's configure an AP group, and I'm just going to call it example. And let's also configure a WLAN virtual AP example VAP. And let's go back to our AP group and apply the example VAP to that AP group. Okay, oops. Let me try that again. Begin WLAN virtual. Okay, so we can see the changes that I made here. We have the WLAN virtual AP example VAP, and we have the AP group example, which has that virtual AP applied to it. Okay, and then over here, show run begin WLAN virtual AP. We have the default one, and we have the default AP group, but we do not have those other components. Alright, so this is the unconfigured, unlicensed controller, and I'm going to make it the master. Let's see what configuration I have right now. Show run begin VRRP. I have the IP address and the VLAN. That should be enough. So I'm going to say no shut, show VRRP, and we can say, okay, so right now it's in the backup state. Okay, and it became master because there's no one else running that VRRP instance right now. So let's go over to Master Controller 1. Okay, and what was I doing here? Okay, VRRP 10, no shut. Okay, now that doesn't have any impact at this point. The only thing you're going to see is that this guy's in the backup because he came up second, and this guy is in the master state because he came up first. They have the same priority. Okay, now I'm going to go ahead and configure Master Redundancy, and we're going to see how we lose our configuration. Bang. Master Redundancy, peer IP address 10.0.10.2, IPsec, and admin123. Okay, and we also have to specify which VRRP instance to use, and that's 10. Come over here, Master Redundancy, Master VRRP is 10, and peer IP address is 10.0.10.3, IPsec with a key. Okay, now remember how on this controller we had our example VAP, we had our example AP group, and we also had all of these pre-configured user roles. But since the wrong controller was active, remember this guy's backup, his configuration is now overwritten. Okay, I'm a liar. Okay, so I got worried there for a minute that the exact thing that I was trying to demonstrate wasn't actually happening when I did my recording. Turns out it just took a while for the configuration to sync, and once that happened, all those things that I predicted would happen did happen. So if I say show run at this point, pipe begin user role, we say we have a much smaller list than before as compared to, let me scroll up, as compared to this list. Okay, and if we do show run again, pipe begin WLAN virtual AP, we have our default AP, group, our default virtual AP and our default AP group, but we do not have those ones that I configured that were called example. Okay, and once again, that was because this guy was the master, he did not have the right licenses, and he did not have the right config. So heed my advice. Make sure the correct controller owns the VRRP instance when you configure master redundancy. So I'm going to fix my problem. I'm going to reload that other master controller so that none of the configuration gets saved, and then we'll do this the right way. So I'm going to pause the video while I reload that one. Okay, so my master controller 1 is now back online, and let's just make sure that none of that configuration got lost after the reload. Okay, so my master controller came back online, and unfortunately after the reload that all of those user roles, pre-configured roles, they did not come back the way I expected them to. So I'm actually going to try something a little bit different here. License, remove, delete, yes, the key, and let's add it back, license add. And that brought everything back. Okay, so fortunately I was able to work around that. Let's see, but of course that won't help me with anything that I had started configuring, like, you know, the virtual AP and the AP group, for example. So if I do show run begin WLAN virtual AP, again, those ones that I configured that were called example VAP, and then the AP group that was called example, those are gone. Alright, so that goes to prove the point that I was making with regards to who should be active when you first set this all up. Okay, so all of that being said, let's get this set up the right way. VRRP 10, IP address 10.0.10.4, VLAN 10. Okay, and let's just go ahead and no shut this. And on the other side, my mouse is being wonky. There we go. On the other side, show VRRP. Okay, he's still the master, so I'll go into VRRP 10 and I'll shut him down. Okay, saying I actually need to reboot. I don't think that's true, but let's go ahead and show VRRP at this point. Okay, master controller 1 is the master. That's who I want to be the master. Oops, let's try to fix the position here. Okay, so he's the master. I'm going to no shut. Show VRRP. He is the backup. Let's run it a few times just to make sure he doesn't become the master. Okay, so we know he's not the master. Do it over here one more time just to make sure. Okay, so this guy's definitely the master. That's who we want to be the master. Now we just need to configure master redundancy. I already did it on master controller 2. So let me actually just show you something here. Master controller 2, where I already have master redundancy configured, show IP route. You can see now that if I'm going to talk to 10.0.10.2, it's going to use this IPsec map. Okay, it's the /32 route that gets installed. That happens immediately when you configure master redundancy. And if I do show IP route over here, you can see I don't have that. Okay. So I'm going to turn it on now. Sorry, master redundancy. Peer IP address is 10.0.10.3 IPsec. And then, let's see here. Master VRRP is 10. Okay. Show IP route. You can say we have that new routing entry here with the IPsec map to the /32. We have it over here as well. And at this point, if I show VRRP, we're still the master, and if I do show master redundancy, I'm also the master. Okay. Do it over here as well. Show master redundancy. He's the backup. Perfect. Now if I do show run over here, begin user role. Okay. Well, I don't see the things that I expect to see because I haven't configured centralized licensing. Okay, so let's just get that part out of the way right now. Okay, now that I have master redundancy configured, I can do all the changes on one controller instead of both if it is a change that is intended to be copied between all the controllers. And centralized licensing is one of those things. So, centralized licensing, as I explained before, allows all of the licenses in a master local controller domain to go into one giant pool, and then people can pull from them as they need to. Okay, so all I have to do is say license profile, centralized licensing enable. Okay, that turns the feature on. That's really all I have to do. However, that change isn't going to propagate over to the other controller until I do a write mem. So right now if I say show switches, this is a very important command, show switches, because it will show you all of your controllers in your master local domain. We can see we have master controller 1 and master controller 2 in our domain. They're on configuration ID 1. And if I write mem, do the same command, now master controller 1 is on config ID 2, and master controller 2 is on config ID 1. Okay, but over time, you can see we moved from update required to update in progress, and then in a few seconds, update successful. And so let's see if that carried over. So show license profile on master controller 1, centralized licensing is enabled. Show license profile on master controller 2, we can see it's also enabled over here, which should mean that all of those pre-configured user roles should now exist. Begin user role, and there they are. Perfect. Okay. So, you might ask yourself, why are we using IPsec between our master controllers? And I actually mentioned this in the previous video, but I want to mention it in this one as well. We have sensitive information in our running config that we don't want transiting even our local area network without encryption. So things like the radius and TACX shared keys, as well as WPA passphrases. So let's see. Let's just do an example really quickly here. WLAN SSID profile, delete me. WPA passphrase is 1 2 3 4 5 6 7 8 9 0. Okay, write mem so that goes across. Let's wait for it to finish actually show switches. So this actually takes a while because it's not just configuring, it's not just reading configuration, but there's all kinds of databases that get synchronized between the two master controllers. So it has to pull all those databases and then copy them over. Okay. Let's see here. And if I do show run begin WLAN SSID profile, we can see we have my delete me with the WPA passphrase that's encrypted. All right. So just so you're aware, if you want to decrypt parts of the running config, all we need to do is say encrypt disable. Let's do the same show run. There it is, my WPA passphrase. Okay. I can also see it. Show WLAN SSID profile delete me. There's my WPA passphrase again, and that's because I typed encrypt disable and that showed it to me. That's very similar to the Cisco command service password encryption. Okay, so encrypt disable is going to expose pre-shared keys for WPA and TACX and radius. It will also expose IPsec keys. So if I do show run pipe include IPsec, we can see this is the configuration that came out of Master Redundancy, and there's my IPsec key encrypted, or unencrypted rather. And let's say we have somebody in our guest user database on the local controller. So local user DB guest, add username Tim, password 987654321. Okay. Show local user DB guest. We'll show the usernames and passwords of those types of users. Okay. Encrypt disable will not show things like the enable password, and will not show any of the passwords of the management users. So show run pipe include enable. So enable secret stays encrypted. Show run pipe include management user, and that password stays encrypted as well. Okay, and just to demonstrate, let's turn it off. Encrypt disable. Oh, that didn't change, of course, but if I show local user DB guest, oh, interesting. Encrypt. Oh, of course. I meant to disable encrypt disable, and I wound up typing encrypt disable. Obviously, I meant encrypt enable. Show the WPA passphrase. Now it's re-encrypted. Okay. All right. So next point on my agenda. Let's see. We were talking about master redundancy, and now we have the correct configuration on both of our controllers. Well, what happens if one day one of those controllers reloads and then comes back, and by the time it comes back, configuration changes have taken place? Unfortunately, it won't know about those configuration changes, and there's a chance it could overwrite them. Okay? And the reason could potentially overwrite them is because of spanning tree. So let me show you what I'm talking about here. Show VRRP. We can see right now my priority is tied. Show VRRP. Priority is tied. Okay. At some point, one of these controllers goes down. It comes back, and even even though preemption is disabled on both sides, there is a chance that we could observe that freshly reloaded controller preempting anyway, and this drove me nuts for the longest time. And finally, it was determined that the problem was because of spanning tree. So the VRRP instance would start before spanning tree had a chance to move into the forwarding state, and so we ran into it would run into a situation momentarily where we would have two controllers thinking that they're the master at the same time. So it goes into a tiebreaker, and the lowest MAC address wins. And if that lowest MAC address is the one that has the old configuration is what gets restored to everybody. Okay? We don't want that. So to get around that issue, and I had a big warning about that. Not preemption. So this is everything I just talked about. It has not had enough time to go into the forwarding state. VRRP can start before it's even had a chance to communicate with the counterpart. We could have a dual master situation. Tiebreaker goes to the lowest MAC address. That can cause parts of the configuration to be overwritten. Okay, so we prevent this by assigning a hold down timer or by awarding active master bonus priority. Okay? So I'm going to award some priority to the active master to prevent that from ever happening. VRRP 10, tracking, VRRP master state, virtual router ID. So that's 10. Let's add 10 to the priority. Okay? So that means sorry, that wasn't the command I wanted. Let's negate that. Okay. Tracking, master uptime, 2 minutes, add 10. Okay? If the master has been up for 2 minutes, and it is the current master, it will add 10 to the priority. So let's show VRRP at this point. Tracked priority is now 110. Okay? And that will prevent the situation that I just described where we have a dual master and the tiebreaker goes to the lower MAC address. Okay, I also mentioned you could do a hold down timer. I'm not going to demonstrate that one because I have a perfect use case for that one as well in a future video. Okay, let me open up my cheat sheet, see where we are here. So I didn't, okay, let's talk about preemption. A lot of my customers have asked me, should I preempt? And, you know, I think universally there's no reason to preempt that virtual instance on the master controller. Ever. I can't think of one. Okay? Because if your controller goes down, who knows what configuration changes may have taken place while it was down. And if it comes back up and preempts with its old config, we lose all of that. So we don't ever want preemption on our master controller VRRP instance, and I have a big warning about that one as well. So basically what I just covered, it's almost never a good idea to preempt on the master VRRP, because if it goes offline, we don't know what configuration changes may have happened, and when it comes back, those changes will be lost. Okay? So, just make sure preemption is disabled. You can make sure you do that by saying no preempt. Okay? And that command would take if the VRRP was shut down. But it's disabled anyway, so we're good. Okay. So that's master redundancy. Again, the verification command here is show master redundancy. Do it on the other side, show master redundancy. And also show switches. Okay, now if I'm not on the master controller, I only see this entry. So if I go to the active master controller, show switches, now I actually see both of them. We have one master and one standby. Okay, and they're synchronized on their configuration. Alright. Check my cheat sheet here. Centralized licensing, I went out of order and already did that one, but that was because I needed some configuration to copy over. Okay, and let's see. How to add local controllers. Okay, now on the previous video, we did the initial setup, and one of those lines that I added was the local IP line. So let's go to LMS1, which is the controller that I configured in the last video. Okay, so let's check let's move over to our local controller. And for some reason my enable bypass didn't stick. Enable bypass. Okay. Now, one really easy way to tell if your controller is a master controller or a local controller is to look for one of two commands. One is master IP. This will only show up on a local controller. And I can decrypt that. Encrypt, disable. Has to be done from exec mode. And furthermore, on the master controllers, show run pipe include local IP, which I haven't added any yet. However, we can check the role of the controller in a different way by saying show run, not show run, show switch info. Okay, and we can see our switch role is master. Okay, so on the previous video, we added this master IP line. Now we need to add the local IP line on the master controllers. Local IP. Let's see, that would be, so, let's check my diagram. So 10.0.20.2 and 10.0.20.4. 10.0.20.2 IPsec admin 123. 20.4 IPsec admin 123. And those will show up in our routing table with their own /32 routes using these IPsec maps. Okay, and you can actually see these, how they're configured with their crypto maps and everything in the running config, but I won't do that. Okay, and at this point, if I show switches, hopefully, okay, one of them is there now. Let me just check on this other one. Maybe it just hasn't come online yet, or maybe I forgot to add the master IP config. It's there. Encrypt, disable. Show it again. 10.0 to 10.4. PSEC admin 123. Okay. So they're both correct. Maybe it just takes a while. Show switches. Okay, they're all there. And so anything Wi-Fi impacting. Any Wi-Fi impacting changes that I make on the active master controller is now going to propagate to the standby controller and to all of the local controllers. So one of those impacting changes would be centralized licensing. Show license profile. Centralized licensing is enabled. Show license profile over here. We can see it's enabled over here as well, because that configuration got propagated down. Centralized licensing is disabled by default out of the box. Okay, and we also know that on this particular local controller, show license, I have one license of each type, and on my master controller, show license, I have 3 licenses of each type. On master controller 2, show license, no licenses. Local controller 2, show license, no licenses. So because we have centralized licensing, we should have 4 total licenses available to us on the master controller. So if I do show license server table, we can see our aggregate license count is 4. And we're using one of them because some access point, one of my 3 that I have down there has joined. Or maybe I have a stale entry because I didn't do a write erase all, but either way. Let's see, moving on. We did centralized licensing. We added the local controllers. Let's very quickly assign a location to all of these. So if I do show switches, all of these have the location that says building 1, floor 1. You can put whatever you want in this location field, whatever is helpful to you. You could say, for example, location, and just say Chicago. Or you could say, maybe you have a site name, like SFO for San Francisco. Or you could put a physical address, or a building name, room name, row and rack, whatever you want to put there. So I'm just going to say, let's say, building A, room 1, row 2, rack 3. Okay. And And just for fun, I'm going to change them around a little bit. So for master controller 2, it's still building A, room run, rack 4. And then I'm going to do building B. I don't care. Room 2, row 3, rack 4. Oops. And just for the sake of completeness, and you can see all of those changes that I made now show up in the location. So that's helpful to see exactly where everything is in case you're not naming them according to what their location is. You know, it's also another form of internal documentation, so I can see, oh, I know exactly the physical location of this particular box. Okay? My cheat sheet, so we set the location. Alright, last topic for this video is control plane security. Control plane security is a feature that came out several years ago on the Aruba controllers that makes communication between the controllers and the access points more secure. Okay, so it's going to put some encryption on the control packets and so forth. It's also going to do another function of preventing unauthorized access points from joining the controller. Okay. Now, when this feature first came out, one of Aruba's biggest attack problems was my APs won't join the controller anymore, and that was because control plane security was turned on, but no access points were permitted. Okay, so a lot of engineers started, you know, just as a default thing, they just started disabling control plane security all the time because they didn't really have the security requirement that you know, required them to put restrictions on access points or anything, or they didn't care. All right. I would advise you not to do that, not just for the security reasons, but also because some features on the Aruba controller depend on control plane security being enabled. All right. One of those features is the decrypt tunnel mode for the access point. So decrypt tunnel mode means the access point will decrypt the packet before sending it through its GRE tunnel, as opposed to standard tunnel mode, where the access point will not decrypt the packet and instead send it through a GRE tunnel and the controller will decrypt it. Alright, so most of the time I recommend using standard tunnel mode unless there is some really good reason you want to use decrypt tunnel mode. I've heard that decrypt tunnel mode could give you better performance because there's going to be less fragmentation because of the difference in the MTUs. And also there's a legacy feature called real-time call quality analysis, which will actually say how good your voice calls are. Now they've replaced that feature with a better one in the UCC dashboard, but again, all of those features depend on control plane security being enabled. All right, so let's go ahead. Like I said, no access point is permitted to join when control plane security is enabled, unless we explicitly permit them, or we have permitted them in the past, or something to that nature. Now, control plane security. All right, let's go into that profile. Let's also do show control plane security as well. We can see the feature is enabled and automatic provisioning is disabled. Okay, and since there are no access points except for possibly that one random one that I think may have joined, Since no access points have the correct provisioning certificate on them already, they're not going to be able to join. So to allow any access point to join without disabling control plane security, we are going to say auto cert provision. Okay? Show control plane security. Now auto cert provision is turned on. Let's write mem to propagate that down to all the other controllers. Alright, and that's going to allow any access point to join my master controller, get its encryption certificate from the controller, and we don't have to worry about complications with certain APs can join or not. Okay, they're all going to be allowed to join at this point in time. In the future, I could turn that auto cert provision off, and that will prevent any further APs from joining. Alright, so good security practice. And that's pretty much everything I've wanted to talk about here. Oh, except I have one more warning about control plane security. Let's see, we did VRRP with Master Redundancy, right? Alright, so last final warning here. Changing control plane security settings on a live network. If you enable or disable CPSec, that's the shorthand, while on a live network, all access points are going to reboot, either to get their encryption certificate or to just go back to standard, no control plane security mode. Okay, either way, it's going to require a reboot of the access points. So just make sure it's in the maintenance window. Alright, and that's it for this video. This is Configure This Now. My name is Tim Haney. I hope you've learned something, and see you next time.